Welcome to tonight's video on section P4. This is day 2 of this section. Today we're going to get into the how to use your graphing calculator to solve everybody's favorite concept of a word problem. Alright, so the first thing is make sure when you're doing this that you have your graphing calculator that looks something like this. You can either have an 83 or 84. Because you're going to need it. So make sure you have that handy. Alright, this video is, the beginning part is just going to basically go through the process of what you're going to do, and then we're going to go through some examples. So the first thing when you're reading a word problem here is you clearly want to state what the x and y variables represent. The second thing you're going to do is state the equation. You're going to find 2 points. And if you need to, make sure you reread the word problem carefully. To come up with the 2 points that you're going to use. The reason why it's important to reread the problem carefully and come up with these 2 points is because in order to write the equation, you're going to calculate the slope using the 2 points. Remember the slope formula, y2 minus y1 over x2 minus x1, that whole thing. And then you're going to write the equation in point slope form. Remember point slope form, y minus y1 equals m times x minus x1. And then you're going to convert it into slope intercept form. Y equals mx plus b, because when you type it in your calculator, as I'm going to show you right here, that's how you're going to have to type in equations, is you're going to have to put them in slope intercept form, like 5x plus 3. Okay, so when you graph them, it has to be in slope intercept form, and you hit graph and it graphs it when you have the right window. Let's do it that way. There you go. It'll graph it. See? 5x plus 3. And I'll explain to you how to get the windows and everything right coming up. Alright. So that is step 2. Step 3 is you're going to enter the equation in the calculator like I showed you. Use the y equals button right here. This is the button you press. So let's say we weren't in there. Let's say we were just in this space here and we want to type in an equation. We hit y equals. Like that. And notice you can type in your equation, whatever you want. I'm going to clear that for now. Alright. So the next thing we want to do is state the domain and range. And remember, the domain is x. So you want to think about, what do x and y represent? You also want to think about, can x be negative? If you're talking about years, you can't have negative years. So you have to ask yourself, can x be negative? Are there any restrictions? Are there any restrictions? This is the most important step, because this will determine if you can find the answer or not. So make sure, as we practice, you get good at finding the domain and range. Number 5 is you'll enter the domain and range in the x-min and x-max for the domain and y-min and y-max for the range. So basically, the domain and range come under the window button. And notice there's an x-min and x-max, y-min and y-max. So let's say your domain was from 0 to 5. So you type in 0 and then maximum of 5. you'll always keep the x scale at 1. Let's say the y minimum was 0 and the y maximum was 500, and you'll keep the y scale at 1. And then you graph it. Notice it makes, well, we have to have an equation. Let's say we did 15x, there's the x, plus 25, and then we graph it. Notice there's your equation on that scale. There's your graph. All right, so, but anytime you want to put x max, x min, you hit the window key, window button. All right, now, sometimes you will need to make an estimate. Estimator? No, just estimate. All right, you'll need to make an estimate. For x max or y max, because it's not sure how high or how low or how high you can go on either one of those. The x min and y min will all be set, but you might want to guess for the x max and y max in sometimes, and I'll go over how we're gonna come up with those answers. But sometimes we're gonna have to make an educated guess. All right. So there's a couple different things that you can solve for here. The first thing that you're solve for is an x value. You're given a y value and you want to find the corresponding x value graphically. So basically you're going to set y2 equal to a given value. So let's say on here, you know how we have an equation here, and y2 is going to equal a number that will come up through the problem. Let's say 500. All right. Actually, we'll make it less than 500. 200. So then we graph it. That's the second step. And we're going to look for an intersection. So notice it doesn't intersect here, so let's make the y sub 2 a little smaller. Let's make the y sub 2 25. Actually, we'll make it 55. So notice when we graph it here, notice how it intersects. So what we want to do is find the intersection. And what we're going to do here is we're going to go second function, then trace, and then we're looking for the intersect, so number 5. You can either scroll down to number 5 and hit enter, or you can just hit the number 5 here. And it's going to ask you 3 questions. It's going to say first curve, you're just going to hit enter, second curve, enter, and guess, enter. And it gives you the intersection. So basically, when x equals 2, y equals 55. So basically, you just found that the x value is equal to 2. And that's what, so whatever the x value is, that's what the answer is. The other process that you could do is you could be given the x value and you need to find the y value graphically. So if that's the case, then you need to go to y equals and clear y sub 2, sorry. So let's say you are given that x equals 20. Say you're given x equals 20. Let me first check if that's actually not okay. Let's actually change that to in our domain of 3. We'll say x equals 3. So when we use our calculator here, we're going to graph this. And now to find the y value, you're going to hit the trace key, no second function, and then you're just going to type in 3. And it'll tell you when x equals 3, y equals 70. And that is your answer. So that's how you find the y value if you're given the x. So let's do some examples. So here's the first word problem. So the first question here says the Camelot Apartments purchased a $50,000 building and it depreciates $2,000 per year over a 25-year period. So when they initially purchased the building, it was worth $50,000 and then it depreciated $2,000 per year over a 25-year period. So the first thing we're going to do is say let x equal the number of years after the building was purchased. And we're going to let y equal the dollar value of the building after it was built, after it was purchased. So the first thing we know is basically that there's 2 points. We know when it was purchased, so that's 0 years after it's purchased, it was worth $50,000. That's the first point. And then the second point we know is that it depreciates $2,000 per year. So after year 1, it's now worth $48,000. So those are our 2 points that we came up with. That means our slope, if we go y2 minus y1 over x2 minus x1, it's negative 2,000. So that's our slope. Which means our linear equation, y minus 50,000 equals negative 2,000 times x minus 0. So then we solve, so we get y minus 50,000 equals negative 2,000x, and then you add, so you get negative 2,000x plus 50,000. So that is our equation. So now it wants to know in how many years will the value of the building be 24,500. So 24,500, this is a y value. This is the value of the building. So basically we know 2 things. We know an equation, our y sub 1, our equation is negative 2,000x plus 50,000. We know our y sub 2 is going to be 24,500. That's y sub 2. That's the value of the building after a certain amount of years. So what we need to do is figure out what the domain and range is of this initial function. Well, the domain, remember domain is x, and x is the number of years it was purchased. Well, it goes from 0 and it's over a 25-year period. So the maximum number of years is 25. So that's our domain. Our range. Well, the initial value of the building is 50,000 and it's depreciating, and it can't depreciate below 0. So the lowest the range could be is 0. The lowest the value of the building is 0. And the highest it can be is 50,000 because it depreciates. So there's our domain and range. So now we're ready to type it in the calculator. Hit Y equals after you turn it on. There you go. Hit Y equals. Let's clear that out. So you go negative 2,000 x plus 50. Oops, didn't get that plus sign in there. Plus 50,000. And then y sub 2 is 24,500. Then we got to change our window. So it's 0 to 25. And then 0 to 50,000. And then you graph it. So notice you get a depreciating line, and notice you get an intersection right there. That's what we're interested in finding. So we go second, trace, down to intersect, and then you hit enter 3 times, and you get that it's 12.75 years. So that is our answer. What was the value of the building in 12 years? So notice, x equals 12. So now we know the x value. So we're given x equals 12, and we want to find y. So this is where we're going to hit trace, and then 12, enter. And it's going to give us our answer. So come up here, we eliminate the y sub 2, because remember that's what we're trying to find. So now we graph it, same domain and range, and then we just go trace 12, enter. And so it was worth $26,000 after 12 years. All right, the next problem, Alana plans to invest $27,700, putting part of the money into a savings that pays 3% annually and the rest into an account that pays 1% annually. So let X equal the dollar amount Alana invested or invests at 3%, and Y is equal to the total interest at the end of the year. So remember from Algebra 2, when we do these types of problems, we make a little chart. So we have the 3% account, we have the 1% account, we have the amount invested, we have the rate, and we have the interest. So the amount invested at 3% we don't know, but we know at 1% it would be the rest, so 27,700 minus X. We know the rate here, it's 3%. Here it's 1%. So we know this is 0.03X, and we know this is 0.01X times, or not 0.01X, but 0.01 times, green, 0.01 times 27,700 minus X. So our equation for y would be 0.03x plus 0.01 times 27,700 minus x. That is our equation that describes the total interest at the end of the year. Our domain, well, what can x be? Well, x, remember, the amount of money you have, the most amount is 27,700. The least amount of money you would have was 0. So that is your domain. Your range, how much interest you can earn. Well, you can earn 0. And the most you could earn, well, if you put it all in the 3%, 0.03 times 27,700 would give you $831. So that is the most you could earn. So that would be the top of your range. So how much did Alana invest at 3% if she earned $431 of interest? So this is telling you y sub 2, and you're trying to find the x. So your y sub 1, when you put it in the calculator, is going to be the equation 0.03x plus 0.01 times 27,700 minus x, and y sub 2 is 431. So what you're going to do, hit y equals, clear your last one, so you go 0.03x plus 0.01 times 27,100 minus x. So that's your y sub 1. Y sub 2 is 431. Your window, your x minimum is 0, your x maximum is 27,700. And your y minimum is 0, your y maximum is 831. Graph it. So notice you're trying to find the intersection point, which is here. So you go second, trace, intersect, and then you hit enter 3 times, and you get 7,700. So basically, after you do that, you find out that it's $7,700 that you invested at 3%. Now, the next question says, you invest $325 at 3%. How much total interest did you receive at the end of the year? So here, you know x is 325. So you want to find y. So we're going to go trace 325, enter. So once again, you hit that, you clear. Oh, I shouldn't have actually cleared that one. Sorry about that, don't clear it. So you got 27,700. Sorry, 0.03x plus 0.01 times 27,700 minus x, and then you graph it, and then you got to hit trace, and then 325, enter. So basically, it's $283.50. That's how much interest she received at the end of the year. All right, I know this video was a little longer than the normal, but the calculator stuff takes a while. We'll practice this in class, and we'll spend a couple days on this as well to get used to the process. All right, have a good evening.